wastewater treatment plant, and should we build it? The wastewater, the lodging yang busuk tu. Yang busuk. Yeah, I think kena lah kan bina, kalau tak nak letak mana all the kumbahan, right?
Yeah, betul-betul, I agree.
So let's wrap it up.
Thank you guys.
Imagine this, you flush your toilet at home and think, okay, problem solved. But actually, that's where the real journey begins. Indah Water Consortium 2 in Putrajaya is one of the branches of Malaysia's National Sewage Treatment Company. During our visit, we got to see how chemical and environmental engineering principles are applied in a real industrial operation. And honestly, it was way more interesting than expected. At Indah Water, wastewater is known as influent. This influence comes from houses, buildings and industries, and it is collected and transported to the treatment plant. From an engineering perspective, the wastewater is first lifted from lower level using a pump sound system, showing the application of mechanical engineering in wastewater treatment. Once it enters the system, the plant uses a combination of mechanical, chemical, and biological processes to transform dirty wastewater into treated effluent water that can be safely discharged into the river. This process is extremely important because untreated wastewater can pollute river, destroy aquatic life, cause eutrophication, and spread waterborne disease. So basically, IWK is acting as a silent protector of the environment and public health. Chemical engineering also plays a big role. During sludge treatment, polymers are added to thicken and dewater the sludge. This converts liquid sludge into solid sludge cake, making it easier to handle, dispose of, or reuse as biofertilizer. What surprised us the most is that sewage doesn't just disappear. The treatment process produces biosolid and biogas, which can be used as a renewable energy sources such as electricity. So instead of being waste, sewage actually becomes something useful. Here's the example of the process flow diagram.
Do you know how wastewater is treated before it is safely released back into the environment? In general, wastewater treatment process at IWK begins with preliminary and primary treatment, where incoming sewage is pumped into the plant, screened to remove large solid and allowed settle in the sedimentation tank. These early stages help reduce the solid loads and prepare the wastewater for biological treatment. After that, sludge handling units such as secondary clarifier, sludge thickener, and dewatering system are used to separate and stabilize the remaining solids. The most critical and interesting unit observed during the visit was the aeration tank operating under the activated sludge process. In this process, wastewater is treated biologically using aerobic microorganisms that consume and break down organic pollutants. To support microbial activity, air is continuously supplied into the tank using a fine bubble diffuser aeration system. This system produces a small air bubbles which increase the surface area for oxygen transfer and improve oxygen mass transfer efficiency. Maintaining sufficient dissolved oxygen levels in the aeration tank is essential because it directly affects microbial growth and treatment efficiency. When enough oxygen is present, microorganisms are able to effectively oxidize organic matter, resulting in significant reduction in biochemical oxygen demand, or called as BOD. Have you ever wondered if wastewater treatment plants are operated in manually or monitored digitally like modern industry? What made the plant more impressive was they are using automation and digital monitoring. Most of the operations were controlled using a SCADA system, which allow operators to monitor parameters such as flow rate, pH, dissolved oxygen, and sludge level in real time. For example, the blower supplying air to the aeration tanks will automatically adjust using feedback control loops, ensuring that oxygen levels remain optimal without constant manual control. So in conclusion, this visit shows how theoretical engineering concepts are applied in real industry settings. The integration of equipment, biological process, and automation at IWK not only improve treatment efficiency, but also supports environmental sustainability.
India Water Consortium, or IWK, has adopted several green manufacturing technologies to support environmental sustainability in Malaysia. Firstly, IWK focuses on waste minimization through biosolids recycling. The wastewater treatment process produces nutrient-rich biosolids that are reused as fertilizer. This reduces the need for chemical fertilizers, improves soil health, supports sustainable agriculture, and minimizes landfill waste. Secondly, IWK integrates renewable energy by producing biogas through an aerobic digestion of sewage sludge. This biogas is converted into electricity for internal use. Currently, 6 treatment plants produce about 10,000 cubic meters of biogas per day, with the potential to generate up to 20 megawatt hours of electricity daily. This helps reduce greenhouse gas emissions and operating costs. Next, IWK promotes water sustainability through biofluent reuse. Treated wastewater is reused for industrial applications, landscaping, non-food crops, and artificial wetlands. This reduces reliance on treated water supplies, especially during droughts. In addition, biosolids are used as a valuable resource rich in nutrients. Research with local universities has shown positive results in supporting non-food agriculture, such as rubber tree cultivation. Lastly, IWK improves energy efficiency by using technologies like variable frequency drive and energy recovery systems, which lower energy consumption and carbon emissions. In conclusion, IWK's green initiative show how wastewater treatment can contribute to renewable energy, sustainable agriculture, and efficient resource management in Malaysia.
Today's era of rapid innovation, AI plays an important role in supporting sustainable production in India Water Consortium, or IWK. AI helps optimizing the use of energy, water, and material by analyzing accurate data, which reduce waste emission and operational costs while improving service quality. AI also support predictive maintenance by detecting earlier sign of equipment failure. AI allow operators to take predictive action, reducing downtime and preventing major system losses. However, AI not fully replace human. Its role focus on task replacement, decision support, and human-in-the-loop system. AI mainly replace repetitive data-intensive data, such as monitoring and data analyzing. At the same time, it supports human decision-making in areas like process optimization, safety management, and quality control. In human-in-the-loop system, AI provide recommendation, but human retain control over critical and ethical decision. The impact of AI on human life include higher productivity, improved safety, and new job opportunities. However, it may also cause job displacement and skill mismatch if reskilling is not properly managed. For the environment, AI improve resource efficiency, emission tracking, and predictive maintenance, helping reduce pollution. Nevertheless, high energy consumption and electronic waste remain challenges. In terms of work stabilization, AI support economic growth, disaster prediction, and better governance. At the same time, it risks such as data privacy issues, misinformation, and cyber threat must be carefully controlled. In conclusion, AI is a supportive tool rather than human replacement, and its benefit depend on responsible use, regulation, and human oversight. Thank you.
Okay, so for our conclusion, the visit to Indah Water Consortium provided valuable exposure to how wastewater is treated using chemical, biological, and mechanical engineering principles in real industrial operations.
Through this visit, students were able to understand full treatment process from influence collection to the production of third effluents and
useful byproducts such as biosolid and biogas. Overall, your visit enhanced our